everyone, we are Team Hydra. Welcome to the demonstration of our hackathon project CoralWatch. So this is a web-based application designed to monitor, analyze and detect coral health and ocean marine debris using AI-based insight. Let me walk you all through CoralWatch. So this is the homepage where user gets a quick overview of what the CoralWatch does. You can see the project name, a short tagline and the navigation link to the other sections. So first, what are coral reef? Coral reef are often called the rainforest of the sea. They support nearly 25% of all marine life, protect coastal regions from the erosion, and sustain the livelihood of millions of people through tourism and fishing. So, types of corals. First is hard coral, soft coral, and table coral. So, in this section, it is discussed why the coral reef matters, why we must save coral reef, and the urgent need action. And these are the three main reasons behind the bleaching of the corals. First is ocean warming, ocean acidification, and third is debris pollution in the ocean. So, currently the detection of the coral health and debris relies heavily on manual surveys and diver observation. This approach has several challenges. First is it is time consuming and expensive. Second, it covers only small regions at a time. Third, results are often subjective and inaccurate. So there's a limited real-time monitoring capability. That's where our AI-powered solution comes in to make ocean monitoring faster, scalable, and more accurate. We will discuss this section in a while. So this is a heat stress map of the coral reef. Here we can see that there is a scale of 0 to 20 showing the coral reef stress level worldwide. So now let's move to the another section of coral health check. So in this section we can see there is a table distinguishing healthy coral example and unhealthy coral. So we here the signs of the healthy corals are mentioned and signs of the unhealthy coral are mentioned. And here is in this section we can analyze the health by uploading the image. Let me upload the image. Then analyze health. We can clearly see that the AI model has created a bounding box around the coral and mentioned whether it is healthy or bleach. And this 100% is the confidence score of the model. Let's try with another image. Again, we can see that it has identified the coral correctly, and the confidence score is 99%. And for the coral health detection, we have used a dual model approach. First, we have used a YOLO model for the coral detection in the ocean. So coral model returns the output with a bounding box. So we takes the coordinate of the bounding box and crops the image and resize that image into 128 into 128 pixels and feed that image to our classification model, which is a Resonate 50 model. Then that model classifies whether the coral is bleached or healthy. So we can see the scores of the model. These are the matrices of YOLO model, and these are the matrices of the ResNet 50 model, classification model. Second is detect debris section. So here we have mentioned why the debris are, how the debris are impacting the coral health. Then here we can upload the image of the debris to detect the debris in the ocean. See, we can clearly see that it has detected the debris. Let's try with another image. Again, we can see that it has easily detected the debris in the ocean, and this is the confidence score of the model. These are the matrices of the YOLO V11 model, which is used for the debris detection. Let's move to our model section. So in this section, we have discussed the entire pipeline of our project. So first is technology stack. So we have used two YOLO V11 model. One is for coral detection and one is for ocean debris detection. Second is CNN plus LSTM plus ResNet 50 model. So this is an advanced classification model used to. So this model is used for classifying the health of the coral. And third, which is the main thing, we have deployed all the models on the Hugging Face cloud. So rather than running the models locally on our system, we have deployed the models on the cloud and accessing the model using the APIs. So this is the coral detection and classification pipeline. First is detection using YOLO V11. So it identifies the coral structure with the bounding boxes. So we have selected YOLO 11 because it excels at real-time object detection more accurately. Second is pre-processing. So we crop the detected corals using the coordinates of the bounding boxes and resize this into 128 into 128 pixels with because it is a standardized input of our classification model. So third is classification model, which classifies whether the coral is healthy or bleached. If it is healthy, then it is covered with a green box, and if it is bleached, it is covered with a red box. Then this is a development pipeline. Then this is marine debris detection pipeline where we are uploading the image, then feeding this to a YOLO V11 model, then bounding box creation and resultant analysis. So this is a complete overview of our UI. Now now we will take a overview at our Hugging Face cloud. So first, in this space, we have deployed the YOLO V11 model for coral detection. We can see that it is live and we can access it through the API. Second, this space is about the coral health classification. The ResNet model is deployed here, and again, the API is live. Third, in this phase, we have defined the pipeline of our model, coral health model, where all the cropping and resizing of the image happens. Again, it is live. Fourth is debris detection space. Again, it is live and access through the API. We can access through the API. So that's a complete walkthrough of the CoralWatch web application. To summarize, I would say we have overcome all the challenges, resulting in a web application which helps with a better detection and precise classification of corals and debris. Thank you for watching this demonstration.